rules clear. Your goal is to remove all of the blocks, which I probably won't succeed in doing. I haven't played in a long time. But I would like to show you one other rule, but I may fail to do so. Okay. This kind of checkerboarding, not so good. Don't do that when you play. Also very bad. Okay. The one rule which I won't demonstrate here is if you clear a column, then these guys just sort of eat the column. They just move closer to each other. I think usually the right moves to the left one step. Okay, so that's here's a successful execution from the Clickomania website, but I have done it a few times. I haven't in a long time. The only rule is the group that you click on, the connected color chunk, has to be of size greater than 1. Otherwise, you could just keep clicking on everything. So that's why the checkerboarding is bad, because there you have singleton guys. So you may have some singleton guys, but if you're careful, you sometimes can get rid of them. The question is, when can you? And the answer is, it's NP complete. So this was actually my first NP hardness proof, I think ever, definitely of a game. I think ever. So there's a few results here. One is that if you have a single column, that case we can solve. A single row actually behaves the same as a single column, because even though they're asymmetric in general, for when it's one, they're the same. And if you happen to know context-free grammars, then here's the answer. It's not obvious that this is the answer, but this is saying something like, well, it could be you already solved the game, that's the empty string, or it could be you have a solvable game followed by a solvable game. You could just sort of do them separately, and if you're careful, they won't mess each other up, and then you solve the overall game. Or it could be you have a solvable game and you have the same color, one block of the same color on either side. That would also be solvable, because you could just solve the center thing, then these two guys come together, and then you click that group of size 2. Or this could also happen where you solve two things and then 3 blocks come together. And you could also imagine other rules, but it turns out these are enough rules to capture all solvable puzzles for one row column. But that's not a hardness proof, so we won't talk about it. We have 2 NP hardness results. One is for 2 columns and 5 colors, and the other one is a hardness proof for 5 columns and 3 colors. And these are the proofs. This one is 3 partition, this one is 3 sat, so we might talk about that in the 3 sat section of the class, but I'm going to focus here on the 3 partition, 2 columns, 5 colors. Open problem is whether 2 colors you can get any hardness. Question?
Is it obvious that S to SS is
No, it's not obvious that S to SS is valid, because you worry that when you solve one of them, you might eat a group from the right-hand side. But you can prove it's always possible. I don't remember how that proof works, but you can check the paper. Yeah. If you ever go to the course website and watch this lecture or click around the slides of this lecture, it has links to all the papers that I'm talking about. So if you ever want to...
The next time around, you already have some kind of history to build on. And using Poker Tracker to analyze the interesting decision points is really a very effective way to improve your game, because the next time you come to a similar decision, you will already have some memory of what you believed to be right last time you were doing something like this. So what makes a decision point interesting? It's interesting when you aren't sure what the right answer is. And that may seem kind of obvious, but when the expectation of the outcomes is really close together, you're going to sit at the table and you're going to agonize over it. And that's where you see people on television, where they're sitting there for a minute and they're going, oh, I don't know what to do. And those are the interesting decision points. And as you start out, you will find that you really don't know what you're doing a lot. All decision points are going to be interesting until you start to have some kind of heuristic, some kind of rubric for when to call, when to fold. So here is a situation. We are in the big blind. It's 100, 200 blinds. This is a tournament. In this tournament, it was a single table tournament. Let's say you bought in for $10. $50 goes to first place. $30 goes to second place, and $20 goes to third place. So there's 4 players left here. You have a chip stack of 1,430 chips, and the cutoff here, this player, opened all in for 5,700 chips. The player on the button folded, and this player calls for 2,980 chips. So these two guys are already all in. You have ace-queen of clubs, so you're ace-queen suited, and you have 1,430 chips back in this spot. I want you to take a second, and I want you to think about this decision, whether in this spot, knowing nothing about these two players, you don't really know too much about them right now. We'll get into that a little bit later. But without knowing anything really about these guys, they're just your average players in the game. Would you be calling or folding? I want you to think about that for a second. So I'll point out another feature here. For those of you who are familiar with pot odds, your odds here are 3.35 to 1 to call. If this was a cash game, if you had 23% equity against both of those hands, you could call profitably. Obviously, this is a tournament situation, which affects things drastically right here. But yeah, so the total pot size is 4,810. We have 1,430 to call. So if you believe that this is a very easy decision, raise your hand. 1, 2. We've got a few. Awesome. Okay. You guys are right. If you think it's a call, I want you to raise your hand. 1 call. For the people who think it's close, if you think it's a call, raise your hand. 1. Got a few. It's not even close, and it's full. So let me talk a little bit about what's going on in this view. This is from our ICM quiz. Poker Tracker has a feature that lets you practice in these end-of-tournament situations, which you can access through the Tools menu bar, Tools ICM quiz. And in this spot, what it's telling you is if you push based on an average player model for these two players, your equity in the tournament is 9.49%, based on the expectation of this hand against these two players when they're all in for average opponents. That means that you could expect to make $9.49 with the prize